and welcome to Learning During Lockdown. So, the topic that we are going to study today is called sets. So, what are sets? Sets are a specific group of items or numbers, and these items they are called elements. So, yeah, set notations that we need to learn, and a few of them have been listed down below, and then we'll keep on learning as we go along. The first one, it represents A is the set of. That's how the first one is read. And then the second one, it tells us the number of elements of a set A. And then the third one, these two symbols, they can be used to represent a set that has no elements in it. The fourth one states that Z is an element of the set A. And then the fifth one states that Y is not an element of A. First question type that we're going to solve is, well, it's already listed, so let's just do it. List the elements of the following sets. So Z is a set that includes even numbers between 1 to 10 inclusive. So okay, let's choose a color. Yeah, let's go with red. Okay, so Z, they're even numbers, right? So even numbers start with 2. Okay, 4, 6, 8 and 10, as it's inclusive, so we will also be including 10. Moving on, what's the B part? So the set Y contains elements which are the multiples of 2 between 1 to 15. Okay, so Y contains multiples of 2. Okay, so 2, 4, 6, 8, 10, 12 and 14. Yeah, perfect. Awesome, that wasn't hard, right? So like the question just contained a description of the elements of the set, and then we were just asked to list down the elements, and it was pretty easy, right? Like for the first one, we just had to write the even numbers between 1 to 10 inclusive. So inclusive was helpful to decide whether we had to include 10 or not. And then for B part, we had to write the multiples of 2 between 1 to 15. So yeah, awesome. Okay, so that was like the first type of questions that we get. Let's move on to the second one. Okay, so now there are sets which are defined using an algebraic expression. For example, the set that has been stated, it has been described using the algebraic expression x plus 4 is less than 3. And what's the appropriate way to read this statement is that Z is the set of numbers x such that x plus 4 is less than 3. So yeah, okay, moving on. Oh great, now there's a new term that we need to learn, which is called a universal set. Essentially, a universal set is the set that contains all the possible elements of a given set. I mean, it could be Z, it could be A, whatever the set that the question states. With algebraic expressions, we also need the universal set. I mean, like, oh well, you'll see how that works in the question. So let's solve the type 2 question. So the first part for question 2 states that what's our universal set? X is a square number. X is a square number. Okay. And A is less than 26. So if you want to write down A It has to be a square number, and then it has to be less than 26. So you see, without the universal set, we can't really solve this question, since like we wouldn't know how to actually define the elements. So yeah, let's do it. Now x is a square number which is less than 26, so so 1 square, 2 square is 4, 3 square is 9, and 5 square is 25. Oh, let's not forget 16. Cool. Oh well, let's arrange it in ascending order. I don't like how 16 looks at the end. It looks kind of sad, like we missed it out, so I'm gonna write 16 first. Perfect. It was that easy. Let's do B part now. Okay. X is a prime number and it is less than 26, so let's write the elements of set X. Okay, 1 is not a prime number, 2 is a prime number, 3 is a prime number, 4 is not, 5 yeah, 7, 9 no, 10 no, 11, 13, 14 no, 15 no, 16, 17 yeah, 18 no, 19 yes, 20, 21, 22, 23 yes, 24, 25 no. So we can practice one of the set notations here. Let's practice this one with the question. Let's state the number of elements. Yeah, so what's n a here? How many elements does the set A have? 1, 2, 3, 4, 5. So n of A is equal to 5. Let's do the same. Oh, let's change the color. This is not very interesting. Yeah. Okay, so what's n of x? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. Perfect. So yeah, we just practiced one of the set notations. Perfect. Okay,